Alrighty, guys. So this is a concept that we've actually been taught before, but I'm going to go ahead and just talk about it in the way that I do. So today we're going to go ahead and be talking about imaginary numbers. And to be completely honest, numbers make me want to go to sleep. I'm not good at math in any way, shape, or form. But we're going to have to go ahead and learn this concept. And by concept, I mean algebra / imaginary numbers. And I forgot to write that in. So, what are imaginary numbers? Anyways, honestly. According to Wikipedia, an imaginary number is a number that can be written as a real number multiplied by the imaginary unit I, which is defined by the property I squared equals -1. The square of an imaginary number bi is b squared. For example, 5i is an imaginary number and its square is -25, except for 0, which is both real and imaginary. Imaginary numbers produce negative real numbers when squared. But that doesn't make any sense to me. So, for me, I understand something a lot better when I take something and I make it a lot more complicated. And there's me writing out the word complicated. Ta-da! Smiley face. So, basically in the Grecian times, there was this guy named Bombelli, and he created an amazing, wonderful concept, and he named it imaginary numbers. And it's basically the square root of -1 is what equals I. And then another guy named Hamilton decided to break it even more into 1,000 pieces, and he applied the concept to three-dimensional space, which is a wonderful thing. I mean, it's not like I could get any worse. I mean, I can't even pronounce what he calls it. It's quaternion imaginaries, and please don't ask me to explain it. I tried looking up the concept. It's impossible. So, after taking all of this in, I now know that Bombelli was the guy who decided to take the square root of -I and make it I. And basically what all that means is I is basically that little negative number, and then you would be able to simplify the number in the square to its basics and add it to the outside with I. So the negative is going to turn into I, and the inside number is going to become positive. But then you can also break that down and simplify it, which is super cool. Why is it taking me forever to write things? Sorry. So, for my first example, I'm going to do negative square root of -399. So what we're going to do is we're going to move the negative to the outside of the little house, and it's going to become -I, and we're going to break down 399 into 133 and 3, but you can't really simplify past there, therefore it will go ahead and stay -I square root of 399. And that will be our wonderful little answer. So, what am I writing? So for the second example, I'm going to use 15 plus square root of -9, and we're going to move the negative to the outside, so it'll be I square root 9 with the 15 plus on the other side. And you can break down 9 into 3 and 3, but you can't break it down any time past there, which is sad, I guess. And you can simplify that into one huge 3. Ta-da! So the answer that we'll get is 15 plus 3i. Ta-da! Wonderful little answer. I swear. Oh my gosh. So basically, to remember all of this information, we're going to take the names of the two men who came up with the concept, Bombelli and Hamilton. See, they were worth something after all. Why am I drawing a smiley face? So basically, we're going to bomb the negative, which is violent, sorry, and we're going to ham it down and simplify it. It's a pretty basic concept. It's easy, simple, fair, and easy to remember, because you bomb it and then you ham it down, which is a lot of fun. That's pretty much my entire concept, and there's my little presentation for you guys. Thanks for watching. What am I drawing? Oh, okay.